This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at line integrals. Now, I'm just kind of quoting what was in the book, or somewhat quoting. But this has to do with gravitational fields. I'm not a physics person, so you'd be better off with your physics class if you want to know a whole lot of detail on it, or just read the book and it'll give you a brief overview, which our calculus book did. Now these first problems, we're given a path C, and we want to find a piecewise smooth parameterization of it. And note there's more than one correct answer. More than one way to do this. So let's look at our first problem here. These are kind of challenging. Remember piecewise functions from college algebra? Same idea, somewhat. Okay, our first, and we follow the arrows. So our first piece is going from 0, 0 to 3, 4. And we're wanting to find x of t equals, and we're wanting to find what y of t equals. Sometimes these are very simple to see. Like if I specify t is from 0 to 3, then x of t would equal to t. Now the y isn't so easy to get, but let's take a look at it. What we do is we come up with an equation, a times t plus b, and we're going to focus on this in all of these. And then looking at our y values, our first one's 0. So we're going to set that, find whether that's equal to 0. And our second one will be at plus b is equal to our y value, which is 4. Okay. Now remember I said that we're going to, in this particular piece here, go from t is equal to 0 to t equals 3. So for on this one, I'll put in t is equal to 0. And this one I'll put in t is equal to 3. Okay, so I'll plug 0 in for the t, and I got a times 0 plus b is equal to 0, which implies b is equal to 0. Now if I plug 3 in for the t here, I get 3a plus b is equal to 4. Well, the goal was to find out what a and b are, and this one was pretty simple. B is equal to 0, so if we put plug that into this one over here, we get 3a plus 0 is equal to 4. 3a is equal to 4, or a is equal to 4/3. Now our form of this one was at plus b. And we just said a was 4/3, so we got 4/3 t plus b, which is 0. So y is going to equal to 4/3 t. Now the ultimate check on this is to see if it actually works. Because what we're saying here is we're saying r of t is equal to ti plus 4/3 tj, like that. That's our rationale between 0 and 3. Well, let's plug start with our first t value, 0. If I put 0 here, I get x equals 0. That works. If I put 0 here, I get 4/3 times 0, which is 0, which gives us 0. So that works. Now our ending t value is 3. If I put 3 in for the t here, I get x equals 3. That works. If I put 3 here, 4/3 times 3, the 3's cancel, we get y is equal to 4. That works. So that's our first piece. Okay. Second piece. That's going from 3, 4 down here to 3, 0. And again, we're trying to find out what x is going to equal to, and we're trying to find out what y is equal to. And this first piece here went from 0 to 3. So I don't know much about this second one yet, but I know it has to start at 3. Where this one ends t value-wise, this one has to begin. And let's have it go to, I don't know, 6. I can pick any number there. Remember when it said that there's more than one correct answer? There's an infinite number of ways you could do this. I could set t is equal to 10 over here. Now, if you end this one at 3, this one has to start at 3. Well, look at your x values. 3 to 3. So no matter what, x is going to equal to 3. Okay. Now y. Let's see. We got at plus b is equal to 0. Wait a minute. Erase that. I's got off. At plus b is equal to, and we're looking at our y value. It starts at 4, doesn't it? And then at plus b is equal to 0. So again, my starting y value and my ending y value. Starting, ending. Now, we're starting at t is equal to 3. In this one, we're ending when t is equal to 6. So we'll plug these in for t. So that gives us 3a plus b is equal to 4. This one gives us 6a plus b is equal to 0. Now we want to solve this system of equations. So I got, let's see, 6a plus b is equal to 0. This one, I'll multiply everything by -1. So that gives us negative 3a minus b is equal to negative 4. And then we want to use the addition method, the elimination method. 6a minus 3a is 3a. b minus b drops away. 0 minus 4 is negative 4. So we get a is equal to negative 4/3. Well, now we need to find what b is. So I'll plug it in one of my equations. Doesn't matter which one. I guess I'll do this second one. So we got 6a plus b is equal to 0. We just said a was negative 4/3, so I'll plug that in for a. That gives us negative 8 plus b is equal to 0, or b is equal to 8. Which means our form is going to be at plus b. Well, a we said was negative 4/3, so negative 4/3 t plus b, which is 8. So that implies that y is negative 4/3 t plus 8. From t is equal to 3 to t is equal to 6. Well, let's check this. Obviously, it doesn't matter what I put in for t. This is always 3, so that checks. If I put 3 in, 3 here, the 3's would cancel. I got negative 4 plus 8, which gives me 4. That's my starting y value. That works. Let's put 6 in. If I put 6 in for t, then that gives me negative 8 plus 8, which is 0. So that works. So our second piece. These aren't necessarily simple problems. Our second piece is going to look like, was it 3? 3i plus 8 minus 4/3 t. I'll rearrange it like that. J. This is going from 3 to 6 in terms of my t values. Okay, got one more. And okay. So in our last segment, we went from here to here, went from here to here, and we're going to go from here to here. So that's 3, 0 to 0, 0. Now the last one ended at t is equal to 6, so this one has to start at 6. And we might as well just go to 9 to be consistent on this. Again, you can pick any number here. We'll come back to that one. Y of t. Y is equal to 0, y is equal to 0. So no matter what, y is equal to 0. Now for our x, we're going to have at plus b is equal to, and it starts at 3 for x value. And then we'll have at plus b is equal to 0. So it ends at 0. So it goes from x equals 3 to x equals 0. So from 3 to 0. Now, we said we're going from t is equal to 6 to t is equal to 9. So we'll plug in t is equal to 6 here, and t is equal to 9. Has to go in the same order. See how I did the 3 here, did the 0 here? Well, then you put 6 here and 9 here. So I'll plug 6 in for t. So we got 6a plus b is equal to 3. And this one we got 9a plus b is equal to 0. Well, this is a system of equations. We want to solve it. So I got 9a plus b is equal to 0. And I'll multiply everything in this first equation by negative 1. So that gives us negative 6a minus b is equal to negative 3. Well, 9 minus 6 gives us 3a. B minus b drops away, equals negative 3, which tells us a is negative 1. Plug that back into one of our equations, doesn't matter which one. So 9a plus b is equal to 0. So we got 9 times negative 1 plus b is equal to 0, which tells us b is equal to 9. Now again, the form of what we're looking for is at plus b. We just said a was 1, or negative 1. So we got negative 1t plus b, which is 9. So that's 9 minus t. Well, let's check it. We're starting at t is equal to 6. If I put 6 in here, 9 minus 6 is 3. So that gives me the right x value. I'm ending at t is equal to 9. If I put 9 in here, 9 minus 9 is 0. So that gives us the right x value. So for this particular piece then, it looks like this. This is our third piece. Let me see, what was x? 9 minus t, I, plus our y, which is 0, j, which we know is going to drop away. So that just gives us 9 minus ti. And this is from, what did I say, 6 to 9? 6 to 9 for t. Okay, so let's write our answer then. We're going to merge these all together. So our r is going to equal to our first piece. We got ti plus 4/3 tj from 0 to 3. Our second piece is 3i plus 8 minus 4/3 t j from 3 to 6. And then our third piece would be 9 minus ti from 6 to 9. And that's our answer. Kind of the hard problem of this section is to do this this parameterization. I'm going to go ahead and save this page. Now, one thing I will point out is I got a piece of paper here where I already worked the problem. I did it different in this. I went from t is equal 0 to 1, then from t is equal 1 to 2, and t is equal 2 to 3. And I got answers completely different. I mean, there's some similarities, like x here is still 3, y was 0 down here, and so forth. So you're not restricted to any particular t values. Typically, you try to keep these as small as possible because you end up plugging these into integration, evaluating definite integrals. If your numbers get too huge, then it gets kind of hard. I did these just to make sure I had in my mind how to work all of these, but I'm not going off of them unless I get stuck, and then I'll cheat and go look at it. Okay. Let's take a look at our second one here. Find a piecewise smooth parameterization of the path, and we got x squared over 9 plus y squared over 4 is equal to 1. And you see the order is going here. We'll come back to that. First off, if you end up having an x squared and a y squared in here, what you try to do is you try to see if you can write it as a circle of radius 1. And you're sitting there scratching your head. Well, that's what do you mean? It's an ellipse. We can look at it and see that. Well, we're going to try to rewrite this, and you can rewrite this as what's the best way to show it? I guess I can rewrite this as 1/9 x squared plus 1/4 y squared is equal to 1. And I can take this 1/9 and merge it into the power. So that'd be 1/3 x to the second power plus 1/2 y to the second power equals 1. Now you want a radius of 1. Now when you look at this, recall that cosine t squared plus sine t squared is equal to 1. This is why you always get 1 on the right side, and you try to write these as something squared. Because now I can set what's inside of the parentheses equal to each other. So we got 1/3 x is equal to cosine t, and we got 1/2 y is equal to sine t. Now if I solve this for x, multiply both sides by 3, we get x is equal to 3 cosine t, and this one you get y is equal to 2 sine t. This problem's not too bad really. So we're going to have, let me think this through now, so that's our x and that's our y. So we're going to have r is equal to 3 cosine t I plus 2 sine t j. And this is going to go from 0 to 2 pi. Now there is no piecewise part to this, because we're just continually going around this circle here, or it's not circle, this ellipse. And it starts at the angle 0, and then goes all the way around. That's 2 pi, isn't it? That's why we're going from 0 to 2 pi. And that would be our answer. That one was a lot simpler, even though it seems like they don't give you enough there. Do I have room for the next one? Maybe. Yeah, I guess so. Okay, and this one says find a piecewise smooth parameterization of the path C. Note that there's more than one correct answer. Well, first thing I notice is if we start at 0, 0 here, going up like this is going to the point 4, 2. So it's going from 0, 0 to 4, 2. Now, if I try to figure out what the t value is going to be, then I could go from 0 to 4, which would definitely work. Let me do 0 to 1, change it a little bit. So for this first piece, we're going to go from t is equal to 0 to t equals equal 1. Well, think, and you could do the AT plus B on this to see it and so forth, but 0 to 1, well, 0 would be okay, but if I had a number here times t, well, think what number I'd put there. How about if I put 4t? If I put 0 in, 4 times 0 is 0. If I put 1 in, 4 times 1 is 4. That would work, wouldn't it? So it doesn't have to, this doesn't always have to be t. Okay, now our y of t is probably not going to be as easy. We'll probably have to do our AT plus B bit. Maybe not. 2t. They really are simpler when they start at 0, 0. because if I put 0 in for t, 2 times 0 is 0, so that gives me that y value. If I put 1 in for t, 2 times 1 is 2, that gives me that y value. So this would be our first piece, from 0 to 1. Okay. Now our second piece. Now our second piece has to, if this one ended at 1, then our second piece is going to start at 1. And we might as well go to 2 on that, like that. And the x value. Let's take a look at it. Oops. It starts at what's it start at? 4, 2, and goes to 0, 0. So it's going back. And let me see, plugging one. I'm trying to see if I can eyeball it. I can't see it. Okay, so we got our AT plus B is going to be equal to our beginning x value, which is 4. And we got our AT plus B is going to equal to our ending x value, which was 0. And we're starting at t is equal to 1, and we're ending at t is equal to 2. So if I plug those in, I got A plus B is equal to 4. If I plug 2 in, I got 2A plus B is equal to 0. A lot easier to see if you got starting at 0 like this, then you can just easily come up with it. Well, I want to add these together. So I got 2A plus B is equal to 0. I multiply everything in my first equation by -1. So that gives us negative A minus B is equal to negative 4. Add the equations. 2A minus A is A. B minus B drops away, and that gives us negative 4. Then we want to plug that back into one of our equations and find out what B is. So A we said was negative 4 plus B is equal to 4, so we get B is equal to 8. Now remember, our form is AT plus B. So A was negative 4, so we got negative 4t plus B, which is 8. So 8 minus 4t. Okay. Now, the second one's going to be a lot easier, even though it looks more complex. Our y value is dictated by this right here. Y is equal to square root of x. See how it creates a curve like that? Well, then the question would become, if we have already found x, which we have, we said x was equal to this right here, didn't we? Then y is just going to be the square root of x, which we just said was the square root of 8 minus 4t. And this is our second piece. So when you got a curve like that, it's actually a little bit easier, I think. So our final answer is going to equal to, and this will be a piecewise part. Our first part, we got x and y, so we got 4ti plus 2tj from 0 to 1. And our second piece, we got x, which is 8 minus 4ti, and y, which was square root of 8 minus 4tj, and this is going from 1 to 2. And that'd be our answer. Now again, if you chose different t values, you're going to get different answers, and there's nothing wrong with that. So as weird as it seems, you'll still get the same answer at the end, even if your work looks completely different than somebody else's. Now the hard part on these is what you're just seeing right there. The rest of it is just basic integration. And I've tried to show some challenging problems here at first, so that we can focus more on the formulas and setup, and not so much on the smoothwise parameterization. Now this is how to evaluate line integral as a definite integral. If let f be continuous in a region containing a smooth curve C. If C is given by our r of t is equal to x of ti plus y of tj, where t is between a and b, then our integral is equal to f of x of t, y of t, times the square root of x prime of t squared plus y prime of t squared from a to b with respect to t. And if we've got 3 dimensions, we just add our z part in there. So let's look at a problem. Okay, so evaluate the line integral along the given path. Okay, so we got 2xy c. Now notice something here. They're giving us r, aren't they? That makes our life a lot easier. Plus 4tj. And they're also giving us what t value goes between. Again, makes it super simple then. Okay. Now keep in mind when it's of this form, this is going to be our x of t. So they're telling us x of t is equal to 2t. Oftentimes that's just x equals 2t is how they label it. And this is going to be our y of t is equal to 4t. Or it's just oftentimes y is equal to 4t. Now for our formula, we need to find f of x of t, x of t, y of t. Now f of xy, boy, I'm out of it, is equal to 2xy. So it'll be, this is your function. And they're telling us to plug in x of t, y of t. So where our x is, we're going to put in the 2t. And where our y is, we'll put in the 4t. 2 times 2 is 4, times 4 is 16. T times t is t squared. So that's this first part right here. Well, we need our x prime and y prime. So we got our x prime. Derivative of this is 2. And we need our y prime. Derivative of 4t is 4. And now we're ready to plug it into our formula. Why do people call and not leave a message? Okay. Then the square root of x prime of t squared plus y prime of t squared dt. Okay, so we said t is going from 0 to 1. So we've got 0 to 1. F of x of t, y of t, we said was 16t squared. Then the square root of x prime, which is 2 squared, plus y prime, which is 4 squared dt. Well, 2 squared is 4, 4 squared is 16, so that's square root of 20. I'll go ahead and put it out in front. And actually, I can go ahead and put 16 out in front also. So we're left with t squared dt. Well, square root of 20 reduces to square root of 5 times 16. And to integral this, add 1 to our power, divide by our new power. So that's 1/3 t to the third from 1 to 0. So that gives us 32 square root of 5. And if we plug these values in, we got 1/3 times 1 to the third minus 1/3 times 0 to the third. Well, 0 to the third drops away, so we got 1 to the third, which is 1 times 1/3. So that gives us 32 square root of 5 over 3. And that's our answer. Again, fairly straightforward if they go ahead and give you r of t. Let me go ahead and save that. And the formula kind of drives you exactly what all you need to find. Okay, let me grab a drink here. Let's take a look at this problem. Okay. Let's see, x squared plus y squared minus z ds. And C, yet again we're given r, so that's very nice. Is equal to sine ti plus cosine tj plus 3k. And then t is going to go from 0 to pi over 2. Let's go back to our formula and see what it tells us we need to do. Well, we need to identify x of t and y of t first. That's easy. This is x of t, or some people just write x equals. And this is y of t. And actually this is z of t, because we've got our third dimension thrown in. So we got those. Because we're working with the bottom formula now. So we got x of t, y of t is z of t. Well, now it says we need to find f of that. Well, keep in mind, f of x, y, z is going to equal to x squared plus y squared minus z. Your function is always going to be equal to what's inside the parentheses here. Well, now we want to find f of x of t, y of t, and z of t. So we're going to plug in what we got here. So x we said was sine t, so we're going to have sine t squared plus y, which is cosine. So we have cosine t squared plus minus z, which is 3. Now remember, sine squared plus cosine squared is 1. So this is 1 minus 3 or negative 2. So that's the first part here. They give us the a and b. That's what t falls between. So now we need x prime, y prime, and z prime. So we got our x prime. Derivative of sine is cosine. We got y prime, the derivative of cosine is negative sine. And z prime, the derivative of 3 is 0. So we just found those. So now we're ready to plug in our formula. So our formula says from a to b of f of x of t, y of t, z of t times the square root of x prime of t squared plus y prime of t squared plus z prime of t squared dt. Okay, well we said t is going from 0 to pi over 2. Now f of all that is equal to negative 2, we said. So we got negative 2. And then we got square root. X prime we said was cosine. So we're going to have cosine t squared plus y prime is negative sine. So we're going to have negative sine t squared plus 0 squared dt. Well, the 0 squared drops away. When you square, a negative becomes positive. So basically we got cosine squared plus sine squared, which is 1. So this becomes 0 to pi over 2. I could put negative 2 out in front if I wanted to. And this becomes square root of 1 dt. 0 to pi over 2, 1 dt. And now we're ready to take our integral. Negative 2 stays out in front. The interval of 1 is 1t or just t from 0 to pi over 2. Well, now if we plug in those values, I'm going to have pi over 2 minus 0. Those 2's cancel, and we end up with negative pi for our answer. Don't really have room for an equals on that one, but let me go ahead and save that. Let's take a look at our next one. Now this one gives you a hint. It tells you got to find your parameterization of the path C. So you have to do what we did initially and then evaluate the integral. So it's not as straightforward as plugging in like the last one. Let's get a drink. Okay, let's first look at the parameterization. This is going from 0 to 0, 0, oops, to 3, 1. And 0, 0 to 3, 1. Well, if I try and find x of t and y of t. If I actually specify that t is going from 0 to 3, and again, it makes it a little bit harder when we plug in the 3. 1s are always nice, so we could set it up as 0 to 1, but we'll go 0 to 3. Then this would automatically be t. Because if I put 0 in for t, we'd have 0, which gives us our first x value. If I plug 3 in for t, it gives us 3, which is our second x value. So that works for that. We just need to find out what the y is. So we got, remember our formula, at plus b is equal to our beginning y value, which was 0. And we got at plus b is equal to our ending y value, which is 1. And we're going from t is equal to 0 to t is equal to 3. So here I'll plug in t is equal to 0, and here I'll plug in t is equal to 3. So we got a times 0 plus b equals 0, which gives us b is equal to 0. On this one, we plug 3 in for t, and we got 3a plus b is equal to 1. Now if I plug the b is equal to 0 into that, we got 3a plus 0 is equal to 1, or a is equal to 1/3. Now remember, this is of the form at plus b. We said b was 0, so that drops away, and a is 1/3, so we got 1/3 t. Well, let's see if that works. We plug 0 in for t, and we get 0, which is our beginning y value. If we plug, 0 here, 1/3 times 0 is 0, which is our beginning y value. If I put 3 in for t, I got 1/3 times 3, which is 1, which is our ending y value. So that works. So, now this is going to be how we're going to set up our definite integral from 0 to 3. But now we're given x of t is equal, y of t is equal. I guess I ought to write this problem down before I flip over to the formula. So we got 3x squared minus y squared ds. And we just said that r is going to equal to ti plus 1/3 tj, where this is our x of t and this is our y of t. And we're going from t is equal, I write that down, t is equal to 0 to t is equal to 3. Okay, so now we're ready to go through our formula. Basically, it's the same thing as what we had in these first problems. Okay, so from our formula, we need to identify x of t and y of t. which we did, we need to find f of that. Well, first off, note from our formula over there that f of xy is equal to 3x squared minus y squared. Now we want to find f of x of t, y of t. So x we said was t, so put that in for x, minus, and y we said was 1/3 t, so put that in for y. Okay, so that's going to give us 3t squared minus, that's weird. I just glanced at it. I worked this problem earlier, and I did it the hard way. Let me double check my my stuff up here. I think I checked it. Yeah, 0 under that. 1/3 times 0 is 0. Beginning y value. Put 3 in there. Well, 1/3 times 3 is 1. Sure enough, it's a lot harder the way I came up with it. Assuming I got the order right. Yeah, 0, 0 to 3, 1. How interesting. I'm just going to double check this just a second. 1, yeah. 0, yeah. Fascinating. I guess they are the same thing now that I'm looking at it, but okay, when I square this, that gives us 1/9 t squared, and these both have a t squared, so I can combine them together. Now this one would be what, 27 over 9 t squared minus 1/9 t squared, which gives us 26/9 t squared. Okay, and that's our f of x of t, y of t. I need x prime and y prime. So x prime, the derivative of t is 1, and y prime, the derivative of this is 1/3. Makes me wonder if I get the same answer using what I came up with. 9. That's got me puzzled. Okay, so it's going from A to B. Now we're ready to plug everything in. So it's going from 0 to 3. Remember, these are your t values. And then we want our function next. Our function we said was 26/9 t squared times the square root of x prime squared, which is 1 squared, plus 1/3 squared dt. Well, the 26/9 I can go ahead and put out in front. And that's 0, 3 t squared, and then this becomes 1 plus 1/9 dt. Which I can combine these together as a mixed number. 1 times 9 is 9, plus 1 is 10, so that gives us 10/9 dt. And that's a number we can just put out in front. So that gives us 26 over 9 times, split it up, put a square root on top, square root on the bottom, t squared dt, which gives us 26 square root of 10. Now square root of 9 is 3. 3 times 9 is 27. And then we add 1 to our power, divide by our new power. From 3 to 0. 1/3 I could put out in front. And that gives us 26 square root of 10 over 81. And now we'll plug these numbers in for t. So we got 3 to the 3rd minus 0 to the 3rd. Well, 3 to the 3rd is 27. And so that gives me 26 square root of 10 over 3. Now I'm going to take just a second here and do this integral that the other way I did it and see what I come up with. Assuming my pen would work. I just got that pen. Okay, try another pen. Okay, so we got 0 to 3. 3t squared minus 4/9 t squared. Give you some mood music while I'm doing this. Still doing it. Okay, 0 to 3. 3t squared minus 4/9 t squared plus 4t minus 9 dt. Okay, and that gives us square 13 over 3. Add 1 to the power, so that's t to the third minus 4/27 t to the third plus 2t squared minus 9t. 3 to 0. Okay, where's my calculator? Calculator's gone. There it is. Cleaned my room yesterday. Still can't find everything. Okay, so we got 27 minus 4. That's 9, 18 plus 18 minus 27. 27. It's 27 minus 4. 9, 18 minus 27. Let me double check everything here. Okay, if I have t here, if I put 0 in, that gives me my first x value. Put 3 in, gives me my second x value. Works. Okay, if I put 0 in here, 1/3 times 0 is 0, my first y value. Put 3 in. 1/3 times 3 is 1, my ending y value. Okay, that works. And just double checking here. Oh, I see what I did wrong. Good thing I'm not going off my script. My script would have been wrong. Yeah, I thought everything felt good here when I was doing it. It wasn't like no question on anything. Never mind. My eyes crossed when I was working on a piece of paper and I transposed some numbers. Instead of going from 0 to 1 here, what did I put on my paper? Where's it at? I went from 3 to 1. So from 0 to 1, I went 3 to 1. Well, I went from this x value to that y value. That don't work. These have to be y values here. 0 to 1. And I was talking right then, and I didn't even notice if I saved it. Blah, blah, blah. There's a song. You talk too much, you worry me to death. Good song. 12:02. Yeah, that looks like I did save it. Okay, so let's look at our next one. Another one where we have to find parameterization. Okay, so we got x squared plus y squared ds, and it's counterclockwise around a circle. X squared plus y squared equals 4. But they're only wanting us to go from 2, 0 to 0, 2, or negative 2, 0. So we're only looking at this piece. But nevertheless, we got x squared plus y squared is equal to 4. Remember how I said if you have x squared and y squared, you want to rewrite this so that it's like a circle of radius 1. Well, I can divide everything by 4, so that gives us x squared over 4 plus y squared over 4 is equal to 1, which gives us 1/4 x squared plus 1/4 y squared is equal to 1. And I'll merge that number inside with the x. So that becomes 1/2 x squared plus 1/2 y squared equals 1. Now remember, the cosine t squared plus sine t squared is equal to 1, which means I can equate what's inside the parentheses here. So we're going to have 1/2 x is equal to cosine t, and 1/2 y is equal to sine t. Multiply both sides by 2, and we got x is equal to 2 cosine t, and y is equal to 2 sine t. Now, in terms of what our t goes between, since we're dealing with sine and cosine, we're reduced it to a unicircle, you can obviously see it goes from t is equal to 0 to t is equal to pi. Now, let's say I didn't see that. Well, what you can do is we're given our first point, which is 2, 0, and this is our x, and this is our y. Well, if we come back up to here, we got cosine t is equal to 1/2 x, and we got sine t is equal to 1/2 y. If I plug this x value in, we get 1/2 times 2, which is 1, and we get 1/2 here times 0, which is 0. If you look on your unicircle where you got the point 1, 0, well, that'd be at 0, wouldn't it? So that tells us it starts at 0. Now for our second point, which is -2, 0, if we plug it into the same, cosine t is equal to 1/2 x. If I put -2 in here, -2 divided by 2 is -1. And for our sine, we'd have 1/2 times y, and y is 0, so that'd give us 0. Well, if we look on our unicircle where we got -1, 0, that would tell us t is equal to pi. So that's going to be the setup on that. Now our let me write down what we found. R of t is equal to 2 cosine t I plus 2 sine of t j, from 0 to pi in terms of t. Remember, we need to know what x of t is. That's x of t, and this is y of t. And now let's go back to our formula. Well, we need, first off, I guess we'd go ahead and find x prime, y prime, but we definitely need this part. So remember, f of xy is going to equal to what's inside the parentheses here. So that's x squared plus y squared. And f of, and we'll plug in x of t and y of t. Well, for x, we said x is equal to 2 cosine t. So we're going to have 2 cosine t squared plus y, which is 2 sine t squared, which gives us 4 cosine squared t plus 4 sine squared t. I can factor a 4 out, and that gives us cosine squared plus sine squared, which we know is equal to 1. So 4 times 1 is 4. Okay, well, we need x prime. Well, the derivative of 2 cosine is -2 sine t. And we also need y prime. Derivative of 2 sine is 2 cosine t. Okay, so now we're ready to plug it in our formula. And in case you're wondering, the equals goes along with this one. So, we're continuing on down here, and we're saying this is now equal to, and we're plugging them into our formula. So from A to B, So from 0 to pi. And then we got our function, f of x of t, y of t, which we said was 4. Then the square root of x prime of t squared. X prime we said was negative 2 sine t squared, plus y prime of t squared. So we got 2 cosine t squared dt. Okay, well the 4 we can put clear out in front. And then what's inside here becomes, when you square anything negative, it becomes positive. So we got 4 sine squared t plus 4 cosine squared t dt, which we can factor a 4 out. And that gives us sine squared t plus cosine squared t dt. Sine squared plus cosine squared is 1. So this will be the square root of 4 dt. Now square root of 4 is 2, so we'll put that out in front. And then we're left with the 1 inside here. And the integral of 1 is just t from 0 to pi. Which gives us 8. And we'll plug these in now. Plug pi in for t, minus 0 in for t, which ends up giving us 8 pi. And that's our answer. Let me go ahead and save that. And let's look at our next problem. And let me grab a drink here. Okay. First off, the parameterization. So we've got triangle, vertices 0, 0, 3, 0, and 0, 2. I didn't work this problem right, did I? Triangle, triangle. Nope. Worked a triangle, but I didn't work this one. Okay, counterclockwise. So it's going in that direction. Counterclockwise. So our first one here is going to go from 0, 0 to 3, 0. Well, if I let me try to keep the t values fairly small. If I go from t is equal to 0, t is equal to 1, then this would be 3t. And let me show it. If I plug 0 in for t, 3 times 0 is 0, gives us our beginning x value. And if I plug in 1 for t, 3 times 1 is 3, gives us our ending x value. Now notice on this particular piece here, y is always equal to 0, isn't it? So this is what it would look like. So if I wrote it in terms of our r, this would equal to 3ti from 0 to 1. Okay, that's our first piece. Then we're going from 3, 0 to 0, 2. And I'll choose to go, well, it has to be 1 because that one ended at 1, but I'll choose to go from 1 to 2. Okay. Now our x value. We're going to have at plus b is equal to our beginning x value, which was 3. And then we'll have at plus b is equal to our ending x value, which is 0. And we said we're going from t is equal to 1 to t is equal to 2. So if I plug these in, let me just double check that. 3 to 0, 3 to 0. Okay. If I plug 1 in for that, we get a plus b is equal to 3. If I plug 2 in, I get 2a plus b is equal to 0. And I could multiply this first equation by negative 1. So we got negative a minus b equals negative 3. And add it to my second equation. 2a minus a is a, b minus b drops away, 0 negative 3 gives us negative 3. Which implies, if I put negative 3 in for a, that gives us b is equal to 6. So our form for this one will be at plus b. A we said was negative 3, b is 6. You cannot screw these up if you just immediately check it. It'll tell you whether it worked or not. So if I plug in t is equal to 1, negative 3 times 1 is negative 3 plus 6 is 3. So that's my beginning x value. If I plug in 2, negative 3 times 2 is negative 6 plus 6, which gives us our ending x value. Now let's look at the y's. So we're going to have at plus b is equal to our beginning y value, which is 0. And at plus b is equal to our ending y value, which is 2. So I'm going from 0 to 2. Now in this one we're plugging in t is equal to 1. This one we're plugging in t is equal to 2. So this one gives us a plus b is equal to 0. If I plug 2 in here, I get 2a plus b is equal to 2. Multiply my first equation by negative 1, and we get negative a minus b is equal to 0. Add those. 2a minus a is a, b minus b drops away, 2 and 0 is 2, so we get a is equal to 2, which implies b is equal to negative 2. Now again, our form is at plus b. A we said was 2, so we got 2t minus 2. So 2t minus 2. Let's check it. If I plug 1 in for t, 2 times 1 is 2, minus 2 is 0. That gives us our beginning y value. If I plug in 2, 2 times 2 is 4, 4 minus 2 is 2, gives us our ending y value. I'm probably not going to have room on this piece of paper, so let me jot these down. Okay, so I got r of t is equal to 3ti, that's our first one, from 0 to 1. Okay. Now this one. Our r is going to equal to our negative 3t plus 6 I plus our y, which is 2t minus 2j from 1 to 2. Okay, let me write that down. So we got negative 3t plus 6i plus 2t minus 2j from 1 to 2. Okay, now I'm ready for our last segment. And I guess we're starting at 0, 2. 0, 2. And we're going back to our origin, which is 0, 0. So that's our last segment. Well, first thing I noticed that the x values are the same, aren't they? So x of t is equal to 0. So the only thing we have to worry about is our y of t. Now this one ended at 2, so let's start this one at 2 and have it go to 3. So I'm going to have at plus b is equal to our beginning y value, which is 2, and at plus b is equal to our ending y value, which is 0. Again, I'm looking at my y values, 2 to 0. This one I'm going to plug in t is equal to 2. This one I'll plug in t is equal to 3. So put 2 in for t, and I got 2a plus b is equal to 2. And if I put 3 in for t here, I got 3a plus b is equal to 0. Now I want to multiply my first equation by negative 1. So that gives us negative 2a minus b is equal to negative 2. Add these together. 3a minus 2a is a. That drops away. 0 minus 2 is negative 2, so we get a is equal to negative 2. Which implies b is, if I put negative 2 in for a, I got 2 times negative 2, which is negative 4. Take that over the other side, so that implies b is 6. So our form is AT plus B, and we just said A was negative 2, so we got negative 2t plus 6. Very easy to check. Put 2 in. We got negative 2 times 2 is negative 4 plus 6 is 2. That gives us our beginning y value. If I put 3 in, negative 2 times 3 is negative 6 plus 6 gives us our ending y value. So that works. So our third one is going to be 0, which I don't have to put, negative 2t plus 6j from 2 to 3. Turns out t's. So let me write that down. And let me go ahead and save this page. There we go. And still on number 8. Okay. For our first segment, this is continued. For our first segment, we had said we had r of t is equal to 3ti from t is equal to 0 to t is equal to 1. Well, first thing is we find the integral of this. Then we go to the second segment, then the third segment. And then you add those together and they give you your total value. Okay, so let's go back to our formula. Actually, I better write that down first, I guess. X plus 2 square root of y ds. Okay. In order to use this, we need our a and b, which we got. That's 0 to 1. We need this. So first off, our f of xy is going to equal to x plus 2 square root of y. Keep in mind, this right here is our x of t. So x of t is equal to 3t. And we're wanting to find f of x of t, y of t. Now, x is equal to 3t, so put that in. And y we don't have. Y of t is missing, so that means that's 0. So that's 2 times square root of 0, which gives us 3t. That's what this is. Now we need x prime and y prime. Well, x prime. If x is equal to this, then derivative of 3t is 3. Now for y prime, well, there is no y here, so 0, and derivative of 0 is 0. So now we're ready to do our setup. This is going to go from 0 to 1. And then we'll put our function in. Function was 3t. And the square root of x prime squared. So we're going to have 3 squared plus y prime squared. dt. Okay, well, 3 squared is 9. Square root of 9 is 3. So, and 3 times 3 gives us 9, so we can put that out in front. And then the integral of t would give us 1/2 t squared from 1 to 0. Take the 1/2, put it out in front, so we got 9/2. Put 1 in for t, so we got 1 squared minus 0 in for t, 0 squared, which just gives us 9/2. So let me go ahead and write that down for this first one. 9/2. And let's look at our second segment. Excuse me. Our second segment was r of t is equal to negative 3t plus 6i. Oh boy, I got the hiccups. Plus 2t minus 2j. From 1 to 2. Well, this right here is our x of t, and this right here is our y of t. Back to our formula. we need a and b, which are given. That's 1 to 2. We need to find our function now. Well, remember, our function is the integral up above, x plus 2 square root of y. So x plus 2 square root of y. We now going to plug this in for x, plug this in for y. So f of x of t, y of t is going to equal to negative 3t plus 6 plus 2 square root of 2t minus 2. Not a whole lot of simplifying I can do there. We also need x prime, y prime for our formulas. Well, the derivative of this is negative 3 y prime. Derivative of 2t minus 2 is 2. Okay, so now, let's see, x plus 2 square root of y ds. We can now rewrite this from 1 to 2, and then we put our function in. Function was, what was our function? This right here. So we got negative 3t plus 6 plus 2 square root of 2t minus 2. Oops. Yeah, I want a parentheses there. And then times the square root of x prime. So we got negative 3 squared plus y prime squared, 2 squared, dt. Okay, well, to begin with, this right here, negative 3 squared is 9, 2 squared is 4, that's square root of 13. I can put that out in front. 1 to 2. Actually, I guess I'm just ready to find my integral. I don't need to rewrite that. Maybe I do. Okay, so we got the integral of negative 3t plus 6 dt plus the integral of 2 times the square root. Now, square root is the 1/2 power, so I'll rewrite it that way, dt. Okay, so then this right here, brackets, parentheses, okay, brackets here. Add 1 to your power, so it becomes negative 3/2 t squared. 6 becomes 6t. And this, though I dropped them, go from 1 to 2. Now this over here is a u substitution. If we let u equal to 2t minus 2, du will be 2 dt, which works out pretty nice because we have the 2 in front of it anyway. So all that is accounted for. So this becomes, now these are still t values here, so I'll write them. T is equal to 1, t is equal to 2. And this becomes u to the 1/2 du. Okay. Boy, I'm out of room, almost out of room. This is not good. I was hoping to finish this second segment. Okay, if I plug 2 in, 2 square, I'll make this a little bit easier. 2 squared is 4. That's 2 negative 6 plus 6 times 2 is 12 minus, and I'll plug 1 in. So that gives us negative 3/2 plus 6. Okay, and then plus, let me double check that since I skipped steps. 4, 2, negative 6, 12, put 1 in, I get negative 3/2, 6, okay. Then this, you add 1 to your power, divide by a new power, so we got 2/3 u to the 3/2 from t is equal to 1 to t is equal to 2. So we got square root of 13. Now here's a negative 6. This negative flips this 6, so that gives us another negative 6, which is negative 12, which cancels that, so that just gives us 3/2. Plus, and I can put the 2/3 out in front. And u, we plug back in, was 2t minus 2. t is equal 1, t is equal to 2. I'm going to have room, I think. Fantastic. So square root of 13, 3/2 plus 2/3. Plug 2 in. We got 2 times 2 is 4, minus 2 is 2, minus, and we'll plug 1 in. 2 times 1 is 2, minus 2 is 0. So we got square root of 13, 3/2. 2 minus 0 is 2, times that gives us 4/3. Get a common denominator, multiply this by 3, the top part by 3, so we got 9/6. Plus, multiply the bottom part by 2, top part by 2, we get 8/6, which gives us 17 square root of 13 over 6. So let me write that down. That's our second segment. Let's do our third segment. Okay, this is problem number 8, I think, continued. 8 continued. And again, what we're working with here is x plus 2 square root of y ds. Okay, back to our third segment. Our third segment I wrote down was r is equal to negative 2t plus 6 j from 2 to 3. Okay, so this is our y of t, which means x of t is 0. Back to our formula. Our f of xy is equal to x plus 2 square root of y. And we're wanting to find f of x of t, y of t. Well, we said x of t is 0, so that's 0 plus 2 square root of y of t, which was negative 2t plus 6. So that's us equal to 2 square root of negative 2t plus 6. Well, we need x prime. X prime, if x of t is 0, then x prime is 0. We also need y prime. Well, that's y of t, so the derivative of that is negative 2. Okay, so now we're ready for our setup. This is going from 2 to 3. These are our t values, 2 to 3. Put our function in first. Well, our function we said was this. So we got 2 square root of negative 2t plus 6 times the square root of x prime squared, so we got 0 squared, plus y prime squared, so negative 2 squared dt. Now the 0 squared is 0, negative 2 squared is 4, square root of 4 is 2, so I'll put that 2 out in front. I'll leave this 2 inside for the time being, and this I'll rewrite as negative 2t plus 6 to the 1/2 power dt. Well, this is a u substitution. So we got u is equal to negative 2t plus 6 du. The derivative of that would give us negative 2 dt. Well, we have the 2 in there, but we don't have a negative. That's easy. We'll put a negative out in front. And we'll put a negative inside, because a negative times negative is positive. Okay, so now we're ready to do our substitution. Out in front, 2 times negative 1 is negative 2. These are t values. T is equal to 2 to t is equal to 3. And this becomes u to the 1/2 du. Add 1 to our power, divide by our new power, so that gives us 2/3 u to the 3/2 from t is equal to 2 to t is equal to 3. And we'll plug our u back in. And also take that 2/3 and put it out in front. So we got -2 times 2/3. And u, we said, was -2t plus 6 to the 3/2 power. T is equal to 2 to t is equal to 3. Which gives us -4/3. And we'll plug 3 in. So that gives us -2 times 3, which is -6, plus 6, which is 0, to the 3/2 power. Minus, and we'll plug 2 in. -2 times 2 is -4, plus 6 is 2, so that's 2 to the 3/2 power. Try it again. 3/2. Well, the 0 drops away. Negative times negative is positive, so we got 4/3 times, and I could rewrite this as the square root of 2 to the 3rd, and we can bring a 2 out, so that gives us 4/3 times 2 square root of 2, which gives us 8 square root of 2 over 3. And I believe they're wanting it over the entire area. So those are each individual segment. So if I look at the entire length, then we're going to take our first one we found, which is 9/2, plus our second one, which is 17 square root of 13 over 16, over 6. It'd be a miracle if I didn't make a basic math error somewhere in this. Plus our last one we just found, which was 8 square root of 2 over 3. We can get a common denominator, multiply that by 3, this by 3. Multiply this by 2, and that by 2. And we'd get 27 plus 17 square root of 13 plus 16 square root of 2 all over 6. And that's our answer, finally. So we'll go ahead and save that. Boy, that one took forever. There we go. And let's move on to the next problem. Which I'll need a drink before I start this. So let me grab a drink here. This is 3 dimensions. Find a piecewise smooth parameterization and evaluate an integral. I think you get the idea of exact value. So I may just do the setup on these, and yeah, maybe I should just quit being lazy. Never mind. It probably won't be that bad. Famous last words. Okay, well, first off, we got one segment here, one segment here, one segment here. If you can see the 3D of that. So first segment. It's going from 0, 0, 0 to 3, 0, 0. Oops. Well, this time we need to find, and this is segment 1. Okay, well, this time we need to find x of t, we need to find y of t, and we need to find z of t. Well, some of these are really easy. See how the y values are the same? So y is just 0, and z value is just 0. So the x is the only thing we have to worry about. Now, depending upon what I choose for my t values, and I'm going to go from 0 to 1, then this would be 3t. Because again, if you starts at 0 and goes to a number, it's very easy. You just take this number and put it in front of t. If I check it, if I put 0 in for t, 3 times 0 is 0, gives me my beginning x value. If I put 1 in for t, 3 times 1 is 3, gives me my ending x value. So for our first segment, r is going to equal to 3ti, and those drop away, from 0 to 1. Now let me write this down somewhere. Piece of paper. I guess I can do the same piece of paper here. So segment 1, that's going to be r is equal to 3ti from 0 to 1. Okay, now let's take a look at segment 2. That's going to go from 300 to 302. This is actually not turning out too bad since so many of them are the same. But again, we need our x, we need our y, and we need our z. Well, notice the x value is the same, so it just is 3. And our y values are going to be 0. Z is the only thing we have to worry about. Now, the last one ended at 1, so this one has to start at 1. And let's just have it go to 2. So I'm working on the z's. So I'm going to have AT plus B equals our starting z value, which is 0. And we'll have AT plus B is equal to our ending z value, which is 2. And this will be for t is equal 1, and this will be t is equal to 2. Okay, so if we plug those in, we get a times 1, a, plus b is equal to 0. And on this one, plug 2 in for t, we'll have 2a plus b is equal to 2. Now multiply my first equation by negative 1, so that gives us negative a minus b is equal to 0. 2a minus a is a, b minus b drops away, 2 plus 0 is 2, so we get a is equal to 2, which implies b is equal to negative 2. Now remember, our form is at plus b. We just said a was 2, so we're going to have 2t minus 2. Let's double check this. Plug 1 in for t. 2 times 1 is 2, minus 2 is 0. That gives us our beginning z value. If I plug 2 in, 2 times 2 is 4, minus 2 gives me 2, which is my ending z value. So that works. So this particular piece here, we're going to have r is equal to, now x is 3, so we still have to put that. So that's 3i plus 2t minus 2k. The y is 0, so we don't have to put it. And this goes from 1 to 2. So let me write that down. Equals 3i plus 2t minus 2k from 1 to 2. And let's look at our last segment. Segment 3. And that'll go from 302 to 312. And since this one ended at 2, this one has to start at 2, and I might as well have it go to 3. So we'll go from t equals 2 to t equals 3. Okay. Begin with, we need our x, which x's are the same, aren't they? So that just stays 3. We need our y, and we'll come back to that. And we need our z. Well, z stays at 2, so that's 2. Now for our y's, we're going to have at plus b equals our beginning y value, which is 0. And at plus b is equal to our ending y value, which is 1. So again, it goes from 0 to 1, 0 to 1. And we'll plug in t is equal to 2 here, t is equal to 3. So that gives us 2a plus b equals 0. This one gives us 2a. I'm fading. Let's try that again. Put 2 in for t, and we got 2a plus b equals 0. Yeah, that's right. 3a plus b is equal to 1. I'll multiply the first equation by negative 1. So that gives us negative 2a minus b equals 0. Add these together. 3a minus 2a is a. b minus b drops away. A is equal to 1. Which would imply, if I put 1 in for a, 2 times 1 is 2. Take that over. We get b is equal to negative 2. So this one will be t minus 2. Let's see if that's right. Put 2 in for t. 2 minus 2 is 0. That's our beginning y value. Put 3 in for t. 3 minus 2 is 1. That's our ending y value. So that checks. So this segment here is going to equal to 3i plus t minus 2j plus 2k from t is equal to t is equal to 3. So let me write that one down. Okay, 3. We got r is equal to 3i plus t minus 2j plus 2k from t is equal to t is equal to 3. Okay, let me save this. Number 9 continued. Okay, so now we're going to go back and find our integral, whatever that is. Okay, that's weird. Oh. There. Had a little bit too high. Okay, so that's our integral we're working with. And it's x plus y minus z squared ds. And then we're working with the segment 1, which was r of t is equal to 3ti from 0 to 1. Go back to our formula. Well, we need a and b, which we've got. This is that's the 0 to 1. We need our function. Well, first thing, our f of x, y, z is going to equal to x plus y minus z squared. Always equal to what's inside your parentheses here. Then we want f of x of t, y of t, z of t. Well, this right here, what's before our I is our x of t. So we'll plug 3t in for x. Plus, now we don't have a y of t, so that's 0, minus, and we don't have z of t, which is 0. So that gives us 3t. Now we also need x prime. The derivative of 3t is 3. We need y prime. Since there is no j component here, y is 0, so derivative of that is 0. And we need z prime. There is no k component here, so that means z of t is 0, so z prime is 0. Okay, so then this is going to go from 0 to 1 of our function, and our function we said was 3t, times the square root of x prime squared plus y prime squared plus z prime squared dt. Well, 3 squared is 9, square root of 9 is 3, and that 3 can come out in front, so we got 9 out in front, 0 to 1 of t dt. Which gives us 1/2 t squared from 0 to 1. Take the 1/2, put it out in front, so we got 9/2, 1 squared minus 0 squared, which just gives us 9/2. That's bizarre. That's what we got on the last problem. Okay, so let's work segment 2 now. I'd be tempted to start a new page, but segment 2, is there anything bizarre there that caused us to... We don't have a K. I think we'll be fine. Okay, segment 2. Famous last words. That's what Custer probably said at Little Bighorn. Okay, so we got... No, we do have a K. I was looking at the wrong... My eyes are skipping around. Actually, the last problem was 3ti for the first one, too. Okay. I better cross out this so I don't look down there. Okay, so r in this segment is equal to 3i plus 2t minus 2k from 1 to 2. Okay, so this is going to be our x of t, and this one will be our z of t. We don't have a j in here, so our y of t is 0. So go back to our formula. We got a and b. Want to find our function. F of x, y, z is equal to x plus y minus z squared. X plus y minus z squared. So then we want to plug in f of x of t, y of t, z of t. Well, x we said was 3, so put that in for the x. So we got 3. Y we got 0 minus z, which was 2t minus 2 squared. So 2t minus 2 squared, 2t minus 2. So we got 3 minus, and that gives us 4t squared minus 8t plus 4. Let me double check that. Kind of getting a headache. Okay. So then this gives us negative 4t squared plus 8t, and negative 4 plus 3 gives us negative 1, assuming no basic math error. Well, we also need x prime. Derivative of 3 is 0. Y prime, there is no y, so derivative of 0 is 0. And we need z prime. Derivative of 2t minus 2 is 2. So now we're ready to find this segment. Oops, that should be s, not x. Okay, so we're going to go from 1 to 2, and then we have our function. Well, our function was this right here. So we got negative 4t squared plus 8t minus 1 times the square root of x prime squared. So we got 0 squared plus y prime squared, 0 squared plus z prime squared, which is 2 squared, dt. Zeros drop away. 2 squared is 4, square root of 4 is 2, so I can put that out in front. And then find the integral of this. That gives us negative 4 thirds t to the third plus 8 halves t squared minus t from 1 to 2. And now plug in these numbers. So plug 2 in. 2 to the third is 8 times 4 is 32, so we got negative 32 over 3. Now 8 over 2 is 4, so we got 2 squared, which is 4, times 4, which is 16, minus 2, minus, then we'll plug 1 in. So that gives us negative 4 thirds plus 4 minus 1, which gives us negative negative gives us a positive 4 thirds. I'm going to screw this up if I do that. I'm already skipping some steps, so I'll probably screw it up. 16 minus 2 is 14, plus 4 thirds. 4 minus 1 is 3, with a negative out in front gives us a negative 3. Okay, so that gives us 2 times negative 32 over 3 plus 4 over 3 gives us negative 28 over 3. 14 minus 3 is 11. 11 times 3 is 33. Minus 28 gives us 5 thirds. Assuming I didn't make a basic math error, which gives us 10 thirds. So let me write that down. That's our second segment. So let me go ahead and save this. Wow, I Been going quite a while. I did save it, didn't I? No, I didn't. Okay, so this is 9, I guess, continued. I think it was. Number 9, continued. And we're looking at segment 3, which are R, let me write down, was equal to 3i plus t minus 2j plus 2k from 2 to 3. Well, this is our x of t, this is our y of t, and this is our z of t. Well, our problem was something x plus y minus z squared ds. Okay, back to our formula. First off, our function f of x, y, z is equal to x plus y minus z squared. And then we want to plug in what we just identified, our x of t, our y of t, and our z of t. Now x was 3, so I'll put that in for the x. Y was t minus 2, so plus t minus 2, minus z, which was 2, squared. So we got t, 3 minus 2 is 1, minus 4 is negative 3. Negative 3. Okay, so we need x prime. Derivative of 3 is 0. We need y prime. The derivative of t minus 2 is 1. And we need z prime. The derivative of 2 is 0. So then, this is going to go from 2 to 3. We've got our function, which is t minus 3. Times the square root of x prime squared, so we got 0 squared plus y prime squared plus z prime squared dt. Well, that's all these drop away. 1 squared is 1, square root of 1 is 1, so that even drops away. So the integral of t minus 3 is 1/2 t squared minus 3t from 2 to 3. If we plug 3 in now, we got 1/2 3 squared minus 3 times 3 minus, plug 2 in, and we got 1/2 times 2 squared minus 3 times 2. 3 squared is 9, times a half is 9/2. Negative 3 times 3 is negative 9, minus 2 squared is 4, divided by 2 is 2, minus 3 times 2 is 6. Oops, what am I doing? Okay.
Suspicious item has been detected.
That's interesting. Must click something I didn't mean to. Okay. 2 minus 6 is negative 4, and negative gives us a positive 4, so that gives us negative 5. Negative 5 times 2 is negative 10, plus 1 is negative 1/2. Assuming no basic math error. And since I'm kind of fading a little bit here, it's very likely I did make a basic math error somewhere. So, for a whole part of that, all the segments added together, we got 9/2 plus 10/3 minus 1/2. 9/2 minus 1/2 is 8/2, or 4, plus 10 over 3, which gives us 4 times 3 is 12, plus 10 is 22 over 3. Assuming no basic math error, which I make no assumptions at all in that. Okay, and we're done with that problem. So, number 10. One, find total mass of this. And you'll find that on a lot of these problems after here, Maybe not necessarily in homework, but I've tried to pick problems where I wouldn't spend a huge amount of time on the parameterization, where it's given to us. And I can't guarantee I did that in every problem, but just so this wouldn't be like 4 or 5 hours long. Okay, so R is going to be equal to t squared I, and keep in mind this is your x of t, if need be, plus 3tj, and this will be our y of t. And rho of xy is going to equal to 2y, and t is going to go, it's going to go from 0 to 1. Okay, so that's our setup. And I wrote the formula down at the bottom, or in the hint there. So mass is equal to this formula. It's asking us to find a mass. So our mass is equal to going from A to B, which is your t values. So it's going from 0 to 1. And then your rho comes next. But rho is something special. Here we got rho of xy is equal to 2y. But they want us to have rho of x of t, y of t. So we're going to take what we identified here, x of t is equal to t squared, y of t is equal to 3t, and we'll plug those in. Well, there is no x, so we can ignore that. But y of t is equal to 3t. So we're going to replace the y here with 3t, which gives us 6t. So put 6t here, that's our rho. That's the part right here. Now we need to find this. So we need to r prime first. Well, r prime, the derivative of that would give us 2ti plus 3j. Now this is the magnitude. So the magnitude of that is going to equal the square root of 2t squared plus 3 squared, which is going to give us 4t squared plus 9. So we'll put that here. Square root of 4t squared plus 9 dt. Well, this is a u substitution. If we let u equal to 4t squared plus 9, du would equal to 8t dt. We don't have the 8. We have the t, so that's good. So our mass, I'll go ahead and put the 6 clear out in front, and we're going to put an 8 inside, so I'll offset it with the 1/8 out in front. And we've got our 8t, and I'll rewrite this as 4t squared plus 9 to the 1/2 power dt. And now this matches that. 8t, 8t, dt, dt, so we can do our u substitution. Now 6/8 is 3/4, and these will be t is equal to 0 to t is equal to 1. A lot of books will change these to u values at this point, but I like to do it this way. U to the 1/2 du. Okay. Add 1 to our power, divide by our new power. So that gives us 2/3 u to the 3/2 from t is equal to 0 and t is equal to 1. 2/3 I can put out in front. So we've got 3/4 times 2/3. And u we said was 4t squared plus 9. So I'll plug that back in. 4t squared plus 9 to the 3/2 from t is equal to 0, t is equal to 1. Those 3's cancel, and I got 2/4, which is 1/2. And now let's plug in our numbers. Well, if I plug in 1, 1 squared is 1, times 4 is 4, plus 9 is 13. So we're going to have 13 to the 3/2 minus, now if I plug 0 in for t, 0 squared is 0, times 4 is 0, so we'll have 9 to the 3/2. Now I can put those back in the radical form, and this would be the square root of 13 to the 3rd power minus the square root of 9 to the 3rd power. which would give us 1/2 13 square root of 13 minus 9 square root of 9, which gives us 1/2 13 square root of 13 minus square root of 9 is 3, so that's minus 27. And that's our mass. So let me save that. Now again, that problem was fairly well set up because everything was given to us. But they could throw the parameterization part in there, where you have to find this smooth parameterization first, like we did on our first 3 problems. Let's take a look at number 11. And actually, let me open this up to the book and see if it says what kind of applications are used in this in physics. These are mainly physics problems. Let's see, 15.2. Get there eventually. Looks like these are work problems. Total work can be calculated with this. I think I actually got an example of that. That's the only example I see in the book. But this formula here, we're just looking at how to find it. And then the next piece will be to actually see it in an application. We're finding work done by a force. Okay. So number 11. We got f of xy is equal to x squared y I plus yj. And they give us that c is r of t is equal to 2 cosine ti plus 2 sine t j from 0 to pi over 2. And you notice all the hard part's done for us here. We don't have to do the smooth parameterization. Now our formula is down here. Looks like take our function and we're going to plug in x of t, y of t, and z of t. We need r prime, and then we do the dot product. Okay, so this right here is our x of t, and this is our y of t. So f of xy is given up here, but if I find x of t, y of t, we're going to plug 2 cosine t in for x, so we're going to have 2 cosine t squared y, which is 2 sine t. I made this problem up. I wonder if this will actually even work. I plus, and then y, it'd be the, oops, I can do it right here, 2 sine t j. If we can't easily find the integral, I won't go through this since I made it up, and who knows what in the world I might have done. Okay, so we got that. R prime. R prime. The derivative of 2 cosine is negative 2 sine. So we got negative 2 sine ti. The derivative of sine is cosine, so this becomes plus 2 cosine t j. Now we want to find the dot product of those two. So dot product of that and r prime. So remember the dot product, we multiply what's in front of our eyes. So I'm going to take this 2 cosine t squared, 2 sine t times negative 2 sine t. Well, first off, this squared gives us 4 cosine squared t, and 2 times negative 2 gives us negative 4. And sine t times sine t is sine squared t. Plus, then we multiply what's in front of our j's. So 2 times 2 is 4 sine t cosine t. Well, 4 times negative 4 is negative 16 cosine squared t sine squared t plus 4 sine t cosine t. And it doesn't look like it's going to come out very nice. So I'll just do the setup. Probably the ones in the book will come out nice. Okay, from A to B, so this is 0 to pi over 2. And then we have our dot product, which we just found, which is this. So we'll have negative 16 cosine squared sine squared plus 4 sine cosine dt. Now let me think about this for a minute. The second one's very easy, but the first one's not so simple. I could rewrite like cosine squared is 1 minus sine squared. And it just doesn't work out nice. I'd have to use my power reducing formula and so forth. So let me cheat. After all, I don't want this to go to 5 hours while I'm showing trig substitution and so forth. Okay, so I'm going to go to y equals clear, and I got negative 16 cosine t squared sine t squared plus 4 sine t cosine t. Okay, make sure I'm in radians. So I can press mode. I'm in radians. Now I'll do a second trace. Choose number 7. And wait forever while it graphs this. Should have probably done zoom z-trig to begin with, but that's okay. Lower limit. Okay, 0. Inner, upper limit, pi over 2. And we end up with negative 1.1416. Take it to 4 decimal places using technology. It's not the exact value, but it'll be good enough. Setup is an important part. Showing how you plug in your x of t and y of t, you find r prime, and you find the dot product of them. So I'm going to go ahead and save that. There we go. And let's look at our next problem. This is finding the work. Remember how I said that we're going to look at how to do one of those. Hopefully I made these numbers up better. I didn't work all these ahead of time. They're pretty straightforward formulas. It's like I didn't need to double check myself. I knew how to do them. Mind you, I don't necessarily know how to create a problem so it comes out nice, but that's a different problem. And here we got x is equal to t, y is equal to t squared. This is going from 0, 0 to 3, 9. Now the problem here is find the work done by the find the work done by the force field F on a particle moving along a given path. Okay, well they give us these. Now this is the same as x of t. And this is the same as y of t. So keep that in mind. What they don't give us what t is. Well, let's look at 0, 0. Now this is x and y. Well, if I put 0 in for x, I get 0 is equal to t. If I put 0 in for y, I get 0 is equal to t squared. So we got t is equal to 0, and we got t is equal to 0. What they agree on is your beginning t value. So this is going from t is equal to 0. And then let's look at 3, 9. This is your x and this is your y. So we'll put 3 in for x. We got 3 is equal to t. Put 9 in for y, and we got 9 is equal to t squared. So we get t is equal to 3, and this one gives us t is equal to plus or minus 3. Now again, what they agree on is what you're using. So they both have a t is equal to 3. So this is going from t is equal to 0 to t is equal to 3. Well, let's see our formula. We need our f of x of t, y of t, z of t. That's 3 dimensions, but you could have 2 dimensions, which we do here. So f is equal to this. So f of x of t, y of t, well, that's x of t is equal to t. Y of t is equal to t squared. So we're going to plug those in for the x and y here. So put t in for the x. So I got t squared I plus 3, and then we'll put this t squared in for the y. So we got 3t squared j. Now we also need our r prime. Well, this they don't give us r, but if I were to write it, r is equal to ti plus t squared j. Remember, your x of t and y of t is just what's in front of your i's and your j's. So derivative of that. Derivative of t is 1, so that gives us I. Derivative of t squared is 2t j. Now I'm going to find a dot product of this and this. And I'll kind of shorten the notation. So dot product of these right here. We'll multiply what's in front of our i's. There's a invisible 1 here, so we got t squared times 1, which gives us t squared, plus, and multiply what's in front of our j's. 3 times 2 is 6, and t squared times t is t to the third. So now we're ready to find our work. Work is from a to b, and we said it's from t is equal to 0 to t is equal to 3. The dot product, which we just said was t squared plus 6t to the third dt, which gives us 1/3 t to the third plus 6/4 t to the fourth from 3 to 0. Now the 0 is going to cause everything to drop away, so I just have to worry about the 3. So I got 1/3 times 3 to the third plus 3/2, 6/4 reduces, times 3 to the fourth. So 3 to the third is 27, divided by 3 is 9. 3 to the fourth is 81. Times 3 is 243, I think. Yeah, 243 over 2, which gives us 18 over 2 plus 243 over 2, which gives us 1, 4, 5, 6, 261 over 2, assuming I make a basic math error. And that's our work done. Let me go ahead and save that. Oops. Let's look at our next problem. Grab a drink here. I think I see the end. It's coming. It's coming. 2 hours later. Okay. 13. Look out, Steven Spielberg. I'm coming. Okay. Plus 5y squared dy. And they give us x is equal to 3t and y is equal to 5t. And I meant to put less than or equal to's on those, so they're implied there. It says evaluate the line integral along the path C. Well, if we solve this for t, if I divide both sides by 5, that gives us y over 5 is equal to t. We can then take that and plug that into our other equation. So we got x is equal to 3 times t, which was y over 5. So we got x is equal to 3/5 y. Which means over here, since they already tell us t is going from 0 to 1, they give us a setup there. And we now know what x is, so we could plug that in and see what we come up with. Let me see. Oh, wait a minute. These are y's. What am I doing? I was going to say I'll have y's here, but then I'll have t's there. We need to put y's right here. We'll come back to that. First off, we said x was equal to this, so we're going to have 2 times 3/5 y plus 5y squared dy. Now to find out what our y is, we said y is equal to 5t. So if I plug 0 in for t, we get 5 times 0, we get y is equal to 0. If I plug 1 in for t, I get 5 times 1, which is 5. That's better. These have to match. Everything has to be y's, or everything has to be t's. This is the way that if you got this kind of setup, you don't have to put everything in terms of t's. You can put everything in terms of y's or x's or whatever. So that gives us 6/5 y plus 5y squared dy, which then gives us 6/5 times 1/2 y squared plus 5/3 y to the third from 5 to 0, or 0 to 5. I'm fading. Okay. So that gives us, that reduces a little bit, that gives us 3/5 y squared plus 5/3 y to the third from 0 to 5. We don't have to plug the 0 in, because 0 to the third is 0, drops away, 0 squared is 0, that drops away, so we just plug the 5 in. So we got 3/5 times 5 squared plus 5/3 times 5 to the third. 5 squared is 25, divided by 5 is 5, times 3 is 15. 125 times 5, 625 I think, but let me see. 625. 625 over 3, which gives us, what does it give us? Um, 60, 70, 670 over 3. And that's our answer. So I'm going to go ahead and save that. What did I click? Huh. That's nice. I wonder if I can even save it. Okay. Hopefully it's saved. Otherwise, there'd be a page missing from that. Because I'm not redoing this. Okay, there. Now let me try to save it. 2 hours into the video, my brain's starting to go. Looks like I did save it, but let me just on the safe side. Save it. Okay. Let's look at the next problem. Oh, I lied. There is another parameterization problem here. Okay, this one's an easy one though. 3x plus y dx plus x plus 2y dy. And this is along the x-axis from x equals 0 to x equals 3. Went to y and worked out this morning and kind of sore. Now this is giving us, I think this is differential form, but let me see if they say y, they would put it in differential form. Probably differential equations. It's been a while since I've had that class. Get there eventually. The secondly used form is derived from the vector notation. Doesn't really say why you put it in that form, but it kind of looks like something from differential equations. Okay. Well, first let's work on our smooth parameterization. Okay, I learned to speak someday. Okay, along the x-axis from x equals 0 to x equals 3. So that means we got this point, which is 0, 0, and we got this point, which is 3, 0. So I'm going from 0 to 0, 0, 0 to 3, 0. Well, our x of t, that's going to equal to 3t, and our y of t is going to equal to 0. Going from 0 to 1. Now again, it's pretty easy when you start at the origin. Because if I put 0 in here, 3 times 0 is 0, gives us our beginning x value. If I put 1 in here, 3 times 1 is 3, gives us our ending x value. And then 0 is always 0. Or y is always 0. So now I could also went from 0 to 3, and then this would have been t. So that would have been up to you. So they're telling us, actually I don't need to write that down in this problem. So we got that right there. Well, if I find the derivative of this, then the derivative of 3t will be 3 dt. Drawing a blank. Yeah, there he goes. Okay. Then dy, the derivative of that is 0 dt, so that drops away. Okay, so we can do some substitution now. This is going from 0 to 1. And we know what x is, so we can plug that in. X we said was 3t. So we're going to have 3 times 3t. Y was 0. So that's plus 0. dx, that's 3 dt. Plus x. X we said was 3t. Plus 2 times y, and y is 0. Times dy. Well, that's 0 dt. Well, 0 times all this causes this to drop away. That 0 drops away. 0 to 1. We got a 3 here, 3 here, 3 here. That gives us 27. So I can put the 27 out in front. And we're left with a t there. dt. So then, that becomes 1/2 t squared from 0 to 1. Take the 1/2, put it out in front, so we got 27 halves. Plug 1 in for t, you got 1 squared minus, plug 0 in for t, which ends up giving us 27 halves. And that's our answer. Now, some of the problems in the book are set up such you have to do the smooth parameterization, like we did early on in this video. Let me go ahead and save that. There we go. And let's look at our last problem. Another parameterization. Okay, well, I guess I like doing those. Okay, so f of xy is equal to 3x squared y. And let's see, C is a line that goes from 0, 0 to 2, 5. So I got 0, 0, 5 to 2, 5. So we're going to line from there. And it's in that direction. Is there anything else they give us? Okay. Well, first thing we need is we need our r, because you can see from the formula we need r prime, so you need to find r. And so we're going to go from 0, 0 to 2, 5. And I think this one's fairly simple. X of t is equal to 2t, and y of t is equal to 5t. 0 to 1. Because if I put 0 in, 2 times 0 is 0, our beginning x value. If I put 1 in, 2 times 1 is 2, which is our ending x value. If I put 0 in here, 0 in here, we got 5 times 0, which is 0, our beginning y value. Put 1 in here, we got 5 times 1, which is our ending y value. So r is going to equal to 2ti plus 5tj from 0 to 1. Now for our formula here, we need r prime. Derivative of that is 2i plus 5j. And we need the magnitude of r prime, which is the square root of 2 squared plus 5 squared, which is square root of 29. We also need this. That's f of xy. We need f of x of 2, or boy, I'm fading fast. I'll just quit talking here. So we're going to be plugging in 2t for the x. So we've got 3 times 2t squared, and then we plug the 5t in for the y. So we've got 5t. So that gives us 3 times 4t squared times 5t. 5 times 4 is 20, times 3 is 60. T squared times t is t to the third. Okay, so finally, this is finding the area of the lateral surface. They tell us that the lateral surface area is given using this formula. I'll label it as LSA, lateral surface area. And we're going from 0 to 1. These are our t values from a to b. And we need our function we just found, which was 60t to the third times the magnitude of r prime, which was square root of 29 dt. Well, the 60 square root of 29 I can put clear out in front. And then this is from 0 to 1 of t to the third dt, which gives us 60 square root of 29, 1/4 t to the fourth from 0 to 1. The 1/4 I can put out in front, so we got 60 square root of 29 over 4, and I'll plug 1 in, so we got 1 to the fourth minus, plug 0 in, 0 to the fourth, which just gives us 1. And 60 divided by 4 is 15, so 15 square root of 29 is our answer. And the end of that video, so let me save that. And go ahead and stop the video. This is line integrals, I think. Yeah, line integrals.